Okay? So to solve that, I'm going to go from something called a total differential, and I'm going to turn that into something called a total derivative. So, so, you start out and you say z equals fx dx dz plus fy dy, right? But what I want to know is the dz dx. Because I now know these things are really separate and I can do math operations on them, I can do this. I can divide the equation through by dx. Is that exciting? Yes, it is. So you were going to thinking, oh, there'll be a slow patch. A week or so into the semester, everything will slow down. It won't be as exciting. But this class gets more exciting every day. There's no boring middle of the road thing. Those guys cancel out. What is this? You're like, yeah, it's a badly written equation that I don't have any reason to care about. No! It's an exciting equation. So, what this says is, what's the effect of a change in z, x on change in z, right? What's the effect of changing x? How does that change z? That's what I'm trying to figure out, right? Slope of the line. So I have some function, and I want to know the slope of the line. Okay? How does it change in x? And again, this is three-dimensional. However you want to do that. That should be a surface, but you already know I can't draw, so leave me be. This is the direct effect. This would be what the effect of a change in x is directly on z. Okay? What's this? Well, this is the indirect effect. This is the effect of a change in x on z that comes through y. So this is telling us about the fact that x and y are not independent of each other. That what happens, there's a dependency between x and y. This is the effect that x has on z directly, and this is the effect that changing x causes a change in y, which causes a change in z. Ooh, baby, baby. Okay. So you're saying, well, let's think for a second, because we're in this school thing. Let's think for a second. Let's talk about K-12. Okay? We know that there are certain things in K-12 that have a real effect on student learning. So if we come up with an estimate of student learning, and there's different ways people measure student learning, and the econometrics here is really fun, and I'm trying to get you to realize that what we're doing here is not just theoretical. We want to push it out into, not in this class, but in your next classes. If you're going to take 441, or you're going to go to graduate school and take, 771, 772, 773, take all your econometrics, or whatever you take when you go to, Harvard to get your PhD. There are things that directly affect that output, that we can change those things, and it directly impacts the learning. So we know, for example, that smaller schools are directly connected to learning. The easiest way, the Clark County School District, you know that they're not that interested in student learning, right? Because they build these huge high schools. The high schools in Reno are half the size of the high schools in Vegas. And there's a reason why. Smaller schools get better outcomes. Everything else the same, ceteris paribus, right? Smaller schools create better outcomes. And smaller classes create better outcomes. So I can just change the class size and create better outcomes. But we don't do that either. Okay, we have very large class sizes and very large schools, both of which are going to negatively impact learning. The third thing is the size of the supplies budget. And I'm bringing this up because as we talk, the legislature is talking about cutting the supplies budget for K-12. The supplies budget does have a big effect. The total budget, it turns out if we look across America, it's hard to correlate the total budget for education in a state with outcomes. You have states like Utah that have very low or relatively low, below average spending total on education, but they have higher than average outcomes. Then you have Nevada, which is the lowest spending state on education and has really bad outcomes. And then you have states like Massachusetts that has very high spending and has high outcomes. But you have these states where spending is either high and they get bad outcomes, or spending is low and they get good outcomes. But one thing that clearly correlates is how much money is available for supplies in the classroom. Can a teacher duplicate handouts for class? Do they have art supplies and crayons or whatever it is? Okay? But that effect, the size of that effect, depends on class size. Those two things are not independent. Class size by itself affects learning, but the amount of money you spend on school supplies in the school has less effect the bigger the class size is. Okay? So class size directly affects learning, but the supplies budget affects learning indirectly. Okay? And that may not make much sense, and you may not care about that, but Okay? We excited? All right? So the total derivative, all we do to get the total derivative is, right, the total differential, right? And we could have way more variables. But this is the effect of this on z. This is the effect of that on z. If we say this, now we're isolating out x. And we're getting the direct effect, and we're getting the indirect effect. But now we're just looking at changing x. This equation works if I change both y and x at the same time. I can use this. This is saying we're changing just x, but x and y are related. So a change in x creates a change in y. Okay? All right. Yeah, I know you're excited by that. So if we say z equals x4 plus 8xy plus 3y cubed, right? And yeah, we didn't do that before. But we could find the total derivative of this. The total derivative of this is z equals, yes, 4x cubed plus 8y dx plus, right, the partial of this with respect to x and the partial of this dz dx dz dy, and then we get 8x plus 9y squared dy. And now I just divide that through dz divided by dx. Yes, it looks bad, but you knew my handwriting sucked, yes? By now you know I can't draw, my handwriting's bad. If we were in a real classroom, it would look better because I have the big board and I can write really big. And, you know, I'm better if I write really big. I'm much better. And that's really dx over dx, but we can forget that because that's 1, right? And we get a direct effect and we get an indirect effect of a change in x on z, right? We're directly holding y constant, but y is going to change because X is changing. X is causing a change in Y. So this is the direct effect. This is the indirect effect because X causes, the change in X causes a change in Y. And this is the indirect effect. So Z is going to change by both the fact that X changed it and that X changed Y, which then changes Z. So that's an indirect effect. Okay. I can tell that you're just beyond here, yes? That this is so exciting. I can tell that even though, yeah. So in your book, they want you to do more, all this detailed stuff. They want you to do ISLM and, an open economy, I think, ISLM and some other stuff. And I wouldn't do that. You should read. Reading is not a bad thing, right? Reading's not a bad thing. You should read the first part of 8.5, which is the implicit functions. But then, 8.6, you should read that. Okay? Because it's fun and it's exciting and it just, but I wouldn't go there. Okay? Because, again, many of you are going to go on and take either take 703, take macro in the fall, and you're going to do that in your macro class, and you're going to spend more time on it than we could spend on it in math econ class, because that's not our job. But you're going to get better models, right? And by the way, the person who teaches the first semesters of graduate classes here at UNLV, they have said that people who come through this class do better in their classes than the people who just go to math and learn it from the math department. Okay, we got this? We got this. All right, so we're not going through all the detail in this chapter. We need to understand what a total differential is and a total derivative is, and they're not really hard to find, right? And we need to figure out how to calculate an implicit function, and again, not really hard to do, yes? Then we're going to apply those. The models where we apply those are, generally speaking, more complicated than the models that we've worked on so far. And really, you want to do those in 702 and 703 and later on in life. Okay? We don't really have time to do them all in the summer.